Hi guys, today's video will be a teardown. And as much as possible detailed information about one of the nicest built mini solid state Tesla coils from China that I have found. Look at that. It is so modular. It consists of 3 PCBs. And no focus. Now we have focus. The power PCB, the logic PCB, as we will see later, and the PCB where the secondary coil is, and the primary coil. The primary coil is a PCB based, and the secondary coil is wound. And a third PCB for the top load. I like that really much. It is a very good idea. The design will be probably relatively simple. We will check it, but I like the modularity and it works good, as we will see later. So this is a 30 to 40 euro AliExpress, eBay, STTC solid state Teslacoil that came with interchangeable coil pairs, primary and secondary. When I ordered it, I ordered this one with a changeable top, and I received it with this one. That wasn't what I wanted, because I wanted one that I can change the top load to. So I made a case, and the seller sent me this one in addition. So now I have this both. But you will see it's a very nice design, very compact. And it hides a lot of electronics, a lot of stuff in a very limited space. So we will now tear this thing down and see what it does, what the PCBs do, and what the functional blocks are. Really nice. So, after almost 1 million screws and standoffs, the 3 stores high dual Resonant E-class STTC, that's a mouthful, huh? Teslacoil is separated on its 3 major parts. The first part is this primary and secondary coil pair. The primary is made from a PCB board. To be honest, I do not know how many turns. There can't be many turns, quite a couple of turns. And the secondary, you see here. This beautiful electrical tape is not part of the original construction. It's my help to stop arcs breaking over from the top to the coil itself, because you see arcs that go like that, and a few go like that. And if this continues, it will destroy the secondary coil. So I added an additional layer of insulation. The first one, initially, as I said, came with this coil pair, where the top load is glued on a PCB at the end of the secondary coil. But I wanted something like that, so I can change the top load and put on it whatever I want. This is the second one I received, coil pair, and again my beautiful gray electrical tape for insulation. So let's take a look now what the other two layers are that this quite nice solid-state Tesla coil consists. First of all, this thing, if you see it for the first time, whoa, it looks like a lot is going on here. Complicated. Well, no, it's not complicated at all. Yeah. And I will explain the functionality of these things. First of all, let's have a look on this beautiful heatsink they used. It's a heatsink for a LED light, for LED lights, and they just used it for cooling the two MOSFETs here and the ferrite chucks. Let's start with the things that I like. The first thing is that I like, honestly, even if it's round, I like the construction. I'm not a fan of round things, because if this was square, they could have used a standard heatsink with a fan, with a 50 by 50 millimeter or 60 by 60 millimeter fan. Yeah? But anyway, it is nice. I like the modularity. This is how these things goes together. It's quite difficult at the camera. And on top of that, you have the coil. The whole Teslacoil, the whole electronics of the Teslacoil, the oscillator itself, the power electronics are on this board. And as I said, it looks quite complicated, but it isn't. I did reversed completely this board, this PCB, because this is the most interesting thing. This is the Teslacoil itself. That's it. Everything else is power supply stuff and interrupter and Bluetooth music interrupter stuff, nothing else. So let's take a look of this one, of this PCB, because this is the interesting one. They call it a dual resonant class E solid state Teslacoil. Long name, yeah. To be honest, it's a mishmash of many designs that comes together in one. Don't misunderstand me. This thing works. I wanted to speak in German now. Works perfectly here. It functions perfectly, but it has a lot of very interesting design decisions that they made. And let's go through of them. First of all, let me show you the schematic. Ooh, let's go back here. This is the whole schematic. Let me take something to show you. Don't use my fingers because my fingers are big. This is schematic of the power part itself. Let's go a little bit further back. Yeah. We see here the two MOSFETs. One moment. See here the two MOSFETs that are these two, this and this one. We have the two coils, the two ferrite coils, power chucks, this and this. And we see how the primary coil is connected to the two-legged oscillator. Many people will say, hey, that's a half bridge. No, it's not. It's not a half bridge. It's a dual-ended Class E, but in reality, it's not even a real Class E design, because a Class E design would have here in parallel a capacitor on both sides. This is why I say this is a mixture, a mishmash of many designs, a little bit try and error, till they get the best results. Why dual resonant? Probably, this is my opinion. You have here a parallel resonant, a parallel LC circuit, and here you have a series LC circuit. This is probably the reason why they call it dual resonant. These two capacitors are these ones. This one and this one. The big thing here in the middle is a thermostat switch that when the thing gets hot, it opens. I didn't have another symbol, but I said it's normally closed here. So let's go to the driving circuit. The driving circuit uses a dual gate driver. Nothing very fancy. The whole design is self-oscillating. Hey, what happened? Come on. Focus. Ah, now we have it. It's self-oscillating. When one of these two turns on, produces a magnetic field through the resonant circuit here, and on both sides of the secondary of this coil, there is a voltage, or there is a signal at least. On the bottom side of the secondary is used as a feedback, to go there through a capacitor, a 2-diode limiter that the voltage does not go up or plus or minus 10 or 12 volts, and it is then inverted through one of these inverter gates here. And here we have the first interesting decision that honestly I do not understand. Look at that. They used a complete chip, a SOIC 14 with 6, that consists of 6 inverters. Yeah, this one. And they use only one. They had 6 available. The first thing is, I don't know if you can see it, but let me stabilize it a little bit here. The pins are not even soldered. And why? Because there are not even pads there. You don't have even pads. It's just silk screen, nothing else. I don't understand that. They're using this large chip, and they are not using the inverters, additional inverters, and not even the open inputs are grounded. This thing is prone to oscillate like hell, yeah, or be destroyed, but it works. I never have seen that before. To use a package on the CAD, on the CAD system, that doesn't even have pads for the rest of the, look at here, a little bit better perhaps, I don't know. Let's see, here, yeah. As I said, this thing is not even soldered. It's just silkscreen. They're completely open. They're using only one inverter. These are the 2 limiting diodes, and this is the feedback capacitor. Guys, this is an 0603. Let me show you on the schematic. This is the capacitor, and it's directly connected to the bottom of the secondary coil that produces quite a high voltage, really high voltage and high power. I would never allow in my designs to use a 0603 in this combination at the output of a high power coil. But again, it works and this thing doesn't break through. So, okay, I'm perhaps too conservative, I don't know. Never ever I would do that. It will be a 1210 or a 25 something, 25 or a larger SMD capacitor. The next thing is they're using the signal that comes in is inverted, and they're using the non-inverted part. Why, in the name of God, they didn't use a second gate, inverter gate, in series with this one, so they have a nice 12 volt CMOS output for inverting and non-inverting. Instead, they're just coupling the capacitor output. It has to be an awful signal there directly to the input of the gate driver. I don't understand that. That makes no sense, because they have 6 inverters. They didn't even solder them, the pins on the PCB, because there are no pads there. And that's it. The next interesting is the over temperature protection is this thermostat here, what I said, and this is normally closed. And if it gets hot, it just cuts the 12 volt from the interrupt, from the gate driver. Why? Why they are not cutting the complete voltage here that comes in the 48 volts? Even if this is cut out, if this cuts out the voltage for this gate driver, the rest of the circuitry is completely under voltage. It is. If something happens here, this will burn like a Christmas tree. Yeah. Bad decision. They have a huge thermostat that can handle a lot of amps and a lot of voltage, and they're cutting only the 12 volt supply for this gate driver. Yeah, anyway, these are the things that I do not understand. Yeah, but again, it works. Yeah, the rest of the circuit is on the second level of the second level PCB. It contains the PWM, the frequency, the interrupter. Because if this coil would run on CW mode, it will get overheated in seconds probably. Yeah, this is why an interrupter is used with variable frequency and variable duty cycle. The switch does nothing else than switching between this combination of frequency and duty cycle adjustment and to the output of the Bluetooth module. It is not exactly that you see that's more or less a block diagram. Yeah, nothing else. Yeah, I will show you what happens here and here in a little bit later in another schematic. The rest is power supply. Let's go through the power supply. Here we have the power supply. Because we have here 84 volts and more, they used a switch mode power supply, a pre-regulator. This XML Semi, I used a lot of their products in the past, and again, it's a XL7435. It's a standard back converter. TI would say it's a simple switcher, nothing else. The important thing is that the input of this buck converter, buck chip, goes up to 80 volts. That's the whole magic of that. And now we start again with a design idiom that I don't understand. I do not know at the moment what's the output voltage of that is, but it is a voltage that can feed the 78 M12 and M05, yeah? So it's maximum 35 volts, if it is, or it gets even lower, 20 volts, 25 volts, I don't know. Why they did not make that the output of that is 12 volts, so they do not need the 78 M12 and just cascade the 7805 to have a more clean 12 volt. Come on, the whole circuit, if you see it in a scope, it is noise everywhere, yeah, and it's normal. Anyway, this is the buck converter here, what you see, this part, and this is the input capacitor, the output capacitor of the buck, and the output capacitors of each of the 78 type chips. That's all. This LED, I don't know, I think it shows either that it is on a fixed interrupter modus or on the Bluetooth music mode. I wasn't interested in reverse engineering that. So that's the power supply. Now on the back we have the interrupter circuit and the Bluetooth circuit. They used a ready-made PCB that has an LM339, a comparator, dual comparator, and two 555 timers here. This thing, of course, I didn't reverse engineer it because this is a standard circuitry that they, let's just say, they borrowed from other makers, and they made the PCB. The Bluetooth receiver, I'm just telling from the beginning, do not expect in any way any quality music or perhaps an high voltage speaker quality or something like that. No, it is worse than MIDI music, much worse, yeah. And again, we have the next shitty decision. Why no pads here? I don't understand that. It's just silk screen. There are no pads. Same like the 74HC14 chip that I showed you before, the inverters. Anyway, this is how it looks. Even with all these shortcomings, this thing works perfect. It has a really high output, as we will see later, for this size, and it doesn't really get warm. Now I want to show you a little bit more what this red devil here does. Why is it so bad focused? I don't know. Here we have it again. So let's take a look. This thing, I didn't reverse engineer it. It is just a generic functionality block, how this thing works with, on the left side, a 555 timer with a variable frequency and duty cycle. That's all. That's the one side of the switch. And this is the part that is used on the output of the Bluetooth module to make from a sine wave, more or less, a pulse with modulated signal, a duty cycle modulation. And this is how it works, more or less. As I said, it's a legacy circuit because mine does not have this gain stage here. The whole magic is 1555 timer that produces a sawtooth signal. This is the sampling frequency that is used, fed in one of the comparators. On the other side of the comparator, we have through a capacitor and a level shifter, offset shifter, the sine wave. And at the output, we get something like that. It looks like PCM, but it's not PCM. It's a duty cycle modulation. And this is how you get more or less the music noise, because it's not more than a noise, as you will hear. So this is how it works. And this is what they did on the red PCB without this additional gain stage with an op amp. Even that is missing. From the mechanic point of view, I like it, as I said before. From the base unit, we have only 3 connections to more or less the PCB where the coil itself is. And they are the ones that are soldered. One here, and one here. And which are these? These are these 3. It's this point, and the feedback. So we have the coil between these two MOSFETs, and that's the feedback. That's all. The rest here is just power supply that goes up, and the modulation. The modulation, the interrupter itself. Again, I like this thing, even if it's round, I like it shiny, so nice. Again, 1 potentiometer for the frequency and 1 for the duty cycle, and the duty cycle adjusts the output power of the coil itself. This is the whole magic. So this PCB, the middle PCB, is nothing else than power supply part on the one side and interrupter and Bluetooth on the other, with a lot of interesting design choices that they made, but I don't understand. But anyway, the bottom one is in principle the Teslacoil itself, without the coils. That's all. They even used round tracks. Probably because we have a round design here in general. I don't know. It's just a thought. And the coil itself. For that it is only a couple of turns and they are only made on a PCB, this thing puts a lot of power, outputs a lot of power, as you will see. So, and what time is now? It's time to like my channel and to subscribe, please. If you like what you see, if you like my videos, please hit the like button, subscribe to my channel, and press the bell button, ring the bell. This helps me a lot to show you more of this stuff and more of interesting designs, teardowns, etc. what I'm showing you. So let's see how this thing looks working. So this will get loud, I'm warning you. I connected the Tower of Babel, or the Babylon Tower, together again. The blinking shows that power is applied, 48 volts from this power supply. This gets powered by my isolation transformer and current limited variac. I'm not using the variac functionality at the moment, just the isolation transformer and the current limiting. So I will start with the lowest setting of the power. This is the lowest setting. Let's play with the frequency. And let's make full power. Look, we are already in current limiting. What do you say? For this size, for this baby size, they are nice arcs. They are 15 centimeter arcs, 10 to 15 centimeter arcs. And my hand smells of burnt flesh. Let's say RF, because we have here, I don't know, I think 400 or 500 kilohertz with a lot of power. But I'm used to that. When I was playing with my pirate transmitters in Greece, I was smelling this smell all the time, yeah, because I was touching something and yeah, anyway, this is how it looks. Let's see what we can do more, yeah. I will try to make it to use a Bluetooth, but I have to take my iPad for that. One moment, please. Well, this is what you get from music. This is what I meant, it's all full. I stopped it because it is ridiculous. It's absolutely unnecessary, to be honest. This thing is absolutely unnecessary to use it to have a Bluetooth with that quality. It's ridiculous. It's just to say, yeah, it's another feature that we have. Let me show you how this thing looks. One moment. Where's Bluetooth? Where's Bluetooth? Here's Bluetooth. This is what you see, XFWM18. This is the ID of the Bluetooth module that is connected here. It's all full, yeah. So much better like that. Yeah. Let's go. Okay, guys, enough played. That's for today. Oh my God, I smell burnt flesh. I hope you liked the video. Please subscribe. Please like my videos. Ring the bell button. And see you next time. Cheers. Bye.